Hello guys, this is the final project for ANSYS Fluent. This is going to be part A. We're just going to be developing our wind tunnel. This project is made by Nicolas Giliberti, Raynier Campos, and Tristan Samson. First step is going to be opening my geometry. I'm going to first actually go to my properties, make sure this is 2D so I don't kill myself. And then I'm going to open Design Modeler, and when that opens, I'll get back to the recording. I started doing stuff without recording, but here I just made three lines and I made my dimensions right here, and I'm gonna make my dimensions right here. I'm gonna put my dimension as I believe 1.71176. Enter, and this one as 1.2192, and this one as 1.5748. Perfect. Here's our wind tunnel, what we've developed. We did our face sketch right here, all the sketching. So now we're gonna go into our mesh. So I'm gonna update right there. I'll get back when mesh opens. All right, so now we're at our mesh. I'm gonna create insert method. Select my geometry right there. Apply. I'm gonna make triangles. Some triangles right there. And then generate. Shouldn't take too long. There, as you can see, now we have triangles. And I'm also gonna change my element size. 0.001. For my sake. Here you go. That. Create. Well, actually, I'll just generate right there. Right. Look how great my triangles are. We can probably do more, but it's alright for our purposes. Gonna select control. Right click and create a new section. That doesn't get all. This guy is gonna be called our inlet. I'm just gonna call it velocity inlet. This guy is gonna be called can't type. So that's our mesh. Done and dusted. So now I'm gonna open my setup, but I'll just open my original setup for time purposes. So we're going here and I'll open setup. Starting Fluent, double precision. Why is it opening down here? Viewing. Let's see. Updating, it's loading. I'll get back when it's done. All right, so here we have our beautiful mesh that we just developed. If I go to models and viscous, the first thing I'm going to change is from laminar or inviscid to K epsilon 2. And we change some value over here. Okay. Go to material, air, putting it. Check that everything here is okay. Solid is, should say aluminum. Cell conditions, fluid. Boundary conditions, here we're going to change some things. So after we did our calculations, so you can see we selected 5.8 as our magnitude. But we misinputted right here, 5.625. After we did our height differences, we use area ratios. Well, height ratios to calculate our inlet velocity to get our test section at 15. So I'll apply that there. Close, internal, nothing here. We check outlet, make sure everything's okay here. Perfect. Wall, nothing should change there. Reference frames, got reference values. Make sure this is updated. Nice reference there. Report definitions. Gonna create force report for drag. We're gonna do drag force, and it's gonna be for our wall. Okay. We're just gonna need a drag force because the drag coefficient is gonna be inaccurate. For the case of it, do that. Drag coefficient, the wall, boom, compute when it does it. And then we can initialize. I'm not gonna initialize, well, we're initializing 25 number of iterations, perfect. Initialization shouldn't take too long, but for the iterations, I'm not gonna do 1,000 because it will take way too long for my computer to run. Run calculations, but for our project sakes, we did do 1,000. Actually, I'll just do 1,000. Never mind, doing 500. And once those are done, I will get back. All right, resume recording. Gonna go to my plots, XY plots. Gonna make a few plots. Let me see what we're asked to do for this part of the project. We need pressure, velocity. Wait, let me see. Graphics, contours. Let me make some contours first. First contour we need is static pressure. We need a static pressure, total pressure. So I'll just do all the pressures. So static pressure right here. It's gonna be for my wall. Save and display. Oh wait, never mind. I meant to click all of them. Save and display. Here you go. Zoom in. We can see that we have a high pressure region, and then as the velocity increases, we have a low pressure region, and then as the velocity increases again or decreases again after the test section because of the increase of area, we have low or higher pressure again. There we go. So we can close that guy, make a new contour. All right, well, zooming in into it. Now we're gonna make a contour for our pressure, dynamic pressure. Close here. Look at the dynamic pressure. To every portion of it. And our dynamic pressure is high here because of our velocity. Next contour we need total pressure. Boom. The whole thing. Was this one correct? No, it was wrong. My dynamic pressure was incorrect. There it goes. Now it shows the full thing. Total pressure. And now we need a contour for velocity. So the magnitude. And then here we see the reverse of our pressure. Low velocity as the area decreases, high velocity, and then increase. If we get a zoom in right there. Okay, so that's all for our contours. And then on to our XY plots. All right, next step is my XY plots. So I did make a new surface by doing line, retake. I can just do it again if anything. Call it center line. And at my center, I just do center line. I believe this was already fine, but at, at my center line, I need to find pressure velocity. So my pressure, my static pressure, I'm just gonna do this. Saving like this. Static pressure, dynamic pressure. Like this, perfect. Total pressure. It's all crazy. Make a new one. Save prior, but new one. So line. It's gonna be my vertical line. Make a vertical line now. It's the middle of my thing. 0.0. Wait, now I'm gonna look at my velocity functions. Velocity vertical line should look crazy. Curve length. I also need the center lines for velocity. I didn't know, so I'll just do that right here. It's like that. If I do the curve length one, looks like that, same as the vertical. I also need to this to show my vertical distribution for dynamic pressures. The vertical line, dynamic, and total. There you go. That's all our lines that we needed. And I can just show my reports right here if I can open it. Perfect. Forces, if I do wall 0 to 1, that should be my drag or my drag force right there. And I can also check that out in my other report. My reference values. Oh, wait, they should have recorded here. Here's my drag force and drag coefficient. But obviously the correct values will be calculated in Excel. We got, I believe, a zero, well, for the other parts. So now heading on to results. When it opens, I'll get back. Here I already did it, but here I made the center line, the vertical line, same thing. And here's my streamline for the velocity. See, it's right here. I've been doing it from the inlet and I did only 100 points because if you do more, it kind of won't show. But here's my streamline along the center line. We follow it on, we can see the increase in velocity and then decrease in velocity through the center line. You could also check that out through the vertical line right here. But yeah, that should be all for this video. Gonna start the next video right now. Thank you for watching.